Have you ever just stopped and wondered how your phone, your laptop, and your TV all talk to each other? Like, with no wires, no fuss, it just works? Well, it's not magic, and today, we're going to pull back the curtain on the tech that makes it all happen, your home network.
I mean, really think about it for a second. How is it that you can just tap a button on your phone and a video appears on your TV? Or you can send a document to your printer from the other room. It all feels so seamless, but underneath, there's a powerful, invisible web running right through your house.
And the answer, the absolute hero of this entire story, is something called the local area network. You've probably heard the term LAN before. Well, that's it. It's the silent foundation that makes all of this digital magic possible.
So what in the world is a LAN? Let's break it down, starting with the absolute basics.
A LAN is really just a private little network for a small, specific area. Your house, for example. It uses a lot of the same tech that powers the entire internet, but it's just scaled way down for your own personal space.
And every LAN is built on three key things. First, every single device needs a network interface controller, or a NIC. That's the actual piece of hardware that lets it connect. Baked into that NIC is something called a MAC address, and you can think of that as a totally unique fingerprint for your device. No two are alike. And finally, you have communication protocols. This is just the common language, the set of rules that all your devices agree to use so they can actually understand each other.
Okay, so we know what a LAN is, but how do our devices actually get on the network? Well, you've really got two main options, plugging in a good old cable or riding the airwaves.
So, let's look at the trade-offs here. On one hand, you have Ethernet, the wired connection. It's usually set up in what's called a star topology, which just means every device gets its own dedicated cable plugged right into a central router. That direct line makes it super fast, super stable, and very secure. Then you have Wi-Fi. What you get with Wi-Fi is incredible freedom and convenience, but it absolutely requires strong security, like encryption, to keep your data safe while it's flying through the air. So you're basically choosing between pure speed or go-anywhere convenience.
All right, enough theory. Let's get our hands dirty. How do you actually set up a secure network in your own home? You know, it's probably easier than you think.
It really just comes down to these three steps. You plug your router into the modem, that's what brings the internet into your house. Then you tweak a few settings to lock it down. And finally, you just start connecting your stuff.
Now, if there is one thing, just one thing, you take away from this section, please let it be this. The very first thing you need to do is change the default password on your router. Seriously. Leaving the factory password on there is like leaving your front door wide open with a sign that says, "Welcome."
Next up, you'll set your SSID. It sounds really technical, but I promise it's not. It's just the name of your Wi-Fi network, like Dave's Internet or FBI surveillance van. It's just how you tell your network apart from your neighbors.
And finally, and this is crucial, you'll turn on wireless encryption, specifically WPA2 or the even newer WPA3. This is the security that scrambles all the data flying over your Wi-Fi. It's what stops somebody sitting in their car on the street from snooping on what you're doing online. Using strong encryption is absolutely non-negotiable for a secure network.
Okay, so you've got a secure network up and running. Awesome. But what's the point? Well, one of the biggest payoffs is being able to share files and printers and all that good stuff between your devices.
And when you do share stuff, you're in control. You can give someone read and write access, which is basically full control. They can change or even delete the file. Or you can set it to read only, which is like a look but don't touch rule. They can see the file, but they can't mess with it. This is super important for protecting your original documents.
And of course, this whole idea doesn't just stop at your front door. Think about services like Dropbox or Google Drive. They take this exact concept and make it global, using the entire internet as a giant network, so you can get to your files from anywhere while still giving you that same fine-grained control over who gets to see or edit them.
But what happens when the thing you need to share is absolutely massive, like a full-length movie or a huge software program? If everyone tries to download it from one single server at the same time, you get a digital traffic jam. And that is the exact problem that a really clever system called BitTorrent was built to solve. You see, BitTorrent is what we call a peer-to-peer protocol. So instead of having one central server do all the heavy lifting, it brilliantly spreads the workload across all the computers that are trying to download the file in the first place. It's a team effort.
Here's how the swarm works. Picture it like a group of people putting together a giant puzzle. The main server starts by giving the first person a few pieces. Then, as more people show up, they all start trading the pieces they have with each other. Pretty soon, the whole community is working together to find the pieces they need. And the original server? Its job is done. It can just step back. That's the beauty of BitTorrent. Everyone who downloads is also uploading, turning the entire group into one giant, super efficient, decentralized server.
So, these networking ideas we've been talking about, they're starting to go way beyond just our computers and phones. They're actually forming the foundation for the next huge wave in technology, the Internet of Things.
The Internet of Things, or IoT, is really all about connecting everyday objects to a network. We're talking about everything from your thermostat in your fridge to massive shipping containers and farm equipment, all getting a connection to the internet so we can monitor and interact with them in brand new ways.
But there's a catch. Your standard Wi-Fi connection drinks a ton of power. That's fine for a laptop that's plugged in, but what about a tiny little temperature sensor that has to run for 5 years on a single coin battery? Wi-Fi would kill it in a day. So the IoT needs its own set of special low-power languages.
And to solve that power problem, this whole ecosystem of new technologies has popped up. You've probably heard of some of them, like RFID, NFC, and Bluetooth Low Energy. They're all designed for short-range, super efficient communication. Each one makes different trade-offs with speed and range, but the main goal is always the same. Sip power, don't guzzle it.
In fact, there's a good chance you use one of these every single day. NFC, which stands for Near Field Communication, is the magic behind those tap-to-pay systems, like Apple Pay and Google Pay. It only works when devices are super close. We're talking less than 2 inches apart, which makes it perfect for those quick, secure little exchanges of data.
So, from the simple network that connects our homes to a future where trillions of devices are all chattering away, the fundamental ideas of connectivity are literally reshaping our world. And that leaves us with a pretty big question to think about. As every single object in our lives gets its own digital voice, how are we going to manage that conversation?